Hello everyone, I am Ridu Larkadi. Today I am going to cover a interesting topic from advanced data structure, which is indexing. So let's start with indexing concept. To understand what is indexing, we need to start with what is file. So a file is a collection of records. See, records means lots of data. We have huge data being collected online daily, per minute, per second, through online stuff like newspapers, blogs, social media, or we can say shopping sites, movie reviews, etc. So we must keep this record in organized manner. Why organized? So that we can make use of that huge data being collected to draw some particular conclusions, like that conclusions can help us in making some business analysis or opinion mining, etc. So basically the record must be in organized form. So next point is, what is organization? What is file organization? File organization is physical organization of records. See, many types of file organization exist. It is basically the way records are organized on any physical storage. So one of such organization is sequential organization. Okay, so the best organization is which, where searching type required is least. So to have better organization means what? Least searching time. So to have a least searching time, we have the concept of index. Okay, so now let's see what is index. Index is a collection of key and reference field. Let's take a simple example, like let's take the example of book, the book index. So in book index, we have the list of topics, right, and the page numbers. So let's consider the list of topics as keys, and the page numbers means what? Where the topic will be found. Okay, so page numbers will be your reference fields. Got it? So index to a book provides what? A way to find a topic quickly. Now imagine a book that does not have a good index. What will happen? For searching only one topic, what you need to do? There is only one solution, that you need to scan whole book sequentially, and you know that is time consuming, right? So in simple words, key value and the address where that particular key can be found is nothing but your index. Okay. Now let's think in some other way. Can searching and sorting solve this problem? Or can rearranging all words alphabetically make searching easier? Just think about it. Obviously no. Why? Because indexing works on indirect addressing. Okay, you can observe, like you can imagine, okay, if all the words are alphabetically arranged in any book, it's not a dictionary, it's any book, then there won't be any meaning, and also it will be time consuming. So it's not appropriate. So basically indexing is what? It is a technique of efficiently retrieving the records from any particular file. Yes. You can take one more example, like if there is a huge library, like a central library in your college. Okay, so if you want to locate a particular book, so what can be the index you can form if you want to manage that library? So how you can create the index? Either you can create a card with specific author, or you can create a specific card with the subjects, like like a particular rack is of data structures, a particular rack is of databases, etc., or according to particular author, etc. So what you are doing by using a particular card. Particular card is nothing but a particular index you are finding out, correct? So you can take one more example, like observe on the screen there is one table of roll number, name and standard. Okay, so if that file is having roll number, name of student and his or her standard, okay, then index file can be created of name and address. You can observe the another table, only name and address is given. So whenever you will click or whenever you will find out the address A1, you will get all the information of name Sita, that is his her roll number and standard. So that is considered as index file. This is very small example. We'll look one more example in next slides. Then now the next concept is directory. So directory is a collection of indices. We have just now seen what is index. So when there is a collection of indices, it is called as directory. There are two types of indexes actually. One is dense index, one is non-dense index. So what do you mean by dense index? That I'll tell you now. If an index contains entry for every record, it is called as dense index. Okay, and when there is an entry for only some of the records, then it is non-dense index. Okay, so entry for every index or entry for every record is called as dense index, and entry for only some of the records is called as non-dense. So you can observe in the table that there is one table which is having a record, then EMP number, then name, then occupation of that employee and the disk address. Okay, now observe that table. Suppose P1 to P5 are the disk addresses where these records are stored. Okay, and if I consider a key as employee number, so what will be the index? The index will be, suppose in bracket 100 comma P1. Okay, so likewise 500 comma P2, 444 comma P3, 767 comma P4, 400 comma P5, that will be the indexes, right? So this is considered as dense index. Why? Because the key is distinct for all the records, right? There is an entry for each record, getting? So it is considered as dense index, right? Now let's take one more example. If I consider the key as occupation, so what is occupation? Developer or project head. There are two occupations considered in this particular table. Okay, so if I consider occupation as key, then what will be my index? Suppose let's consider the disk address as Q1. Okay, so how it will be written like index? It will be written like developer comma P1. Sorry, Q we have considered now. So Q1. Okay, so what will be the Q1? Q1, suppose Q1 is a disk address that stores the list of addresses of all the developers. So all the developers means what? P1, P3 and P5, right? Suppose second index will be project head comma Q2. So Q2 is the disk address where list of all the project heads are stored. Now project heads means P2 and P4. So this example also comes under dense index. Why? Because key is distinct for all the records. Right. Now operations. Which operations can be performed on any index? So first operation we can perform on index is search, searching a key. Second, modify, like modifying some entry in that particular index. Third is insert. Insert means what? Inserting any new entry. And delete. Delete means what? Deleting an entry from an index. Right. So this is all about indexing. Now there are some techniques of indexing. There are three techniques of indexing. First is cylinder surface indexing, second is hashed indexing, and third is tree indexing. Out of which first we'll see cylinder surface indexing. So can you observe that cylinder like surface in this particular PPT? Okay, so on this slide, this rectangular things are surface. Okay, then these surfaces are actually divided into some parts. Okay, so that this particular thing is called as track. Everything is stored on that track. Okay, so there are three cylinders are there, right, and all the records are stored on particular tracks. Okay, so I hope you have understood what is track and what is cylinder. So we are going to store something there which will help us in reducing the searching time. Okay, so this cylinder surface indexing is the simplest type of index organization actually. It is very useful for the primary key index of an sequentially ordered file. So the file must be sequentially ordered by something. Some column should be sequentially ordered, and in sequentially ordered file, physical sequence of the records is ordered by the key, some key. So that key is called as primary key. So in following table, or following means in the table which you can observe on slide, roll numbers are arranged sequentially, and roll number can be considered as primary key for the particular table. Okay, or record numbers can be said as primary key. So file will be placed on the hard disk. Now hard disk means what? That cylinders which I have drawn, and to locate the record position, cylinder and surface is used. Okay, so observe that table. In that table, can you observe the record is only name, roll number and marks, but next two columns saying that Sita information of Sita is placed on the cylinder 1 and surface 1. All the information of Ram is placed on cylinder 1 but surface 2. Okay, now I think I missed the point. What is surface, right? So surface are of two types. This front part is called as surface 1. Yes, and the bottom part is called as surface 2. Okay. So now how this indexing works is, we have to check only the highest marks values and that will be retrieved. So now observe on the first cylinder which marks are highest. On first cylinder which marks are highest. First cylinder is having Sita and Ram. Okay, Sita is having 70 marks, Ram is having 80 marks. So on cylinder 1, 80 marks are highest, right? Right. Okay, so there will be one index table, another table. That index table will have two columns only. Which two columns? First is cylinder. First column will be cylinder and second column will be the name of the students who is having highest marks. Okay, so the first entry in that index table will be 1 Ram. Correct. Now what will be the second entry? So we have to check the second cylinder. So second cylinder is having Lakshman and Geeta, out of which highest marks are 96, right? So 96 will be the second entry in our index table. First entry was 1 Ram. Now second entry will be 2 Geeta. And as the third cylinder is having only one entry, that entry will directly go in index table. So this third entry in the index table will be 3 Meena. Correct? So this is end of the part, cylinder surface indexing. Okay. Third, no, second second is what? Hashed indexing. In hashed indexing, it is same as hash table. Okay, but there are some defects in hash table. What that defects are? Good and general purpose hash functions are very difficult to find. Second is what? Static table size requires costly resizing if that indexed set to highly dynamic. Third is what? Search performance degrades considerably as the table nears its capacity. So these are some defects from the hash table. So you are already aware about what is hash table. So it is similar to it. Then last one is tree indexing. In tree indexing, record is arranged in tree structure. Okay, so using it we have some advantages. What advantages? As the structured tree like BST and AVL, uh, it offers you indexing. So they are data independent, self contained, then easily accommodates insertion and deletion. We have to balance the tree in AVL, right? So that balancing is relatively cheap, although it is complex, but the uh, cost required is cheap. It is design wise complex, but calculating efforts are low. Okay, but your tree indexing requires log and search cost, right, which is very much higher than the good hash table. So in tree indexing, the next solution is M-way tree, that is multi-way tree, which we are going to see in our next video. Okay, thank you.